Okay, so we're going to cover Chapter 8, Section 1, and this is going to be on similar polygons. So the first thing that we need to do is understand that similar polygons have corresponding parts, and those corresponding parts will be that their angles are congruent, but their sides are going to be proportional. And the symbol for similar is this wave looking thing here, right here in between. So it's like what's on top of the congruent symbol. So it's a little wave. All right, so this similarity statement that's here in the box is going to be key, because that's going to tell you which angles and which sides match. So notice the A is the first letter, so it's going to match with the M, which is the first letter there. So angles in similar figures are going to be congruent. However, sides are going to be proportional. Then I could match the B with the N. I could add two little congruency marks here. I could match the C, which is the third letter. Match it with the third letter here, which is O. Now, the reason why I'm showing you this is that sometimes they try to trick you and flip the pictures upside down. So these are both sitting the same way, so it's nice and easy. You can see A is congruent to M, B to N, C to O, D to P. The angles have to be congruent. However, notice the sides here. This is called the statement of proportionality, where they take each of the corresponding sides and they match them in a ratio. So notice the first two letters were AB, and they're matching them in the same ratio with MN. So I'm not going to add congruency marks to my picture because they're not congruent, they're just proportional. So that's why you write them in a ratio form or in a fraction form. Then the next two letters, BC, the second and the third letters here, they're going to match with the second and the third, and they've put that in a ratio together, BC over NO. And then we can also match CD, the last two letters, with the last two letters here, and you would put CD over OP. And then lastly, you could match the first and the last, the AD, to the MP, and that's the last fraction. Again, this is called your statement of proportionality. So whenever you take any of these side lengths, they all need to simplify to the same ratio. So I'm going to add some numbers to my picture. So let's say I added a 6 up top here, and then 2 8s on the side, and then a 10 on the bottom. I could put a 3, a 4, and no, that's not a 3. A 3, a 4, a 4, and a 5. Now again, we've already matched the sides. So when I put AB over MN, that's going to be 6 over 3, which simplifies 2 to 1. Then if I take the next two sides, so I've already matched, let's see, these two. Now if I take the second match, BC over here, 8 to 4 simplifies 2 to 1. And then if I do DC to OP, that's 10 to 5, so it's 2 to 1. And then lastly, the same one that I already did, the 8 to 4. Notice they simplify to the same ratio. So because all four sides simplify to the same ratio, I can say that these two polygons are similar. Their angles are congruent, and their sides all are proportional. Pretty good? Okay. So what we're having here are one little picture and one big picture. They're going to be the same shape, but one will be little, one will be big. So a lot of times they would use this for models. Maybe you have a model car, like a toy car, and they may say it's an exact replica of a real thing. It's just scaled down. What a scale factor is. So if you're told that two polygons are similar, then the ratio of the corresponding sides of the two similar polygons becomes the scale factor. You always need to reduce your ratio. Now, the order of the letters is important. And what I mean by this, let's say they ask you to find the scale factor from triangle ABC to DEF. So when I go to write it, I'm going to take a side length from ABC and match it to a side length from DEF. This would be 3 to 6. Now again, there's 3 ways to write a ratio. I don't know if you remember back probably from maybe 6th grade math. You can write a ratio as with the word TO. You can write it as a colon, or you can write it as a fraction. We always need to simplify it, so the scale factor here would simplify to 1 to 2 or 1/2. So again, you could have written your answer with a colon or go back and put the words TO. Now, if the question instead said, find the scale factor from triangle DEF to triangle ABC, then I would go 6 to 3, and my ratio would be 2 to 1. So on a multiple choice test, if this were the question and you picked 1 to 2, you would get it wrong. Okay, so the order matters here. And you always need to simplify the ratio. Everybody good?
I don't understand how to like order the numbers.
They're going to be giving you a statement and they're going to tell you the order to put it. So for example, they'll give you the statement, tell me from DEF to ABC. So what I do is I take a side length from DEF and then I put it to ABC. Or if they said this one, from ABC, so I take an ABC and then I put it over the DEF. Yes?
So it's just proportions.
Yes.
Okay.
Did that answer your question on Zoom?
Yes. Thank
Okay.
you.
So you'll be given this statement and you just match it. Now these were both equilateral triangles, so it didn't matter which side I chose because all sides in the small one were 3 and all sides in the big one were 6.
Miss Corey,
Yes. I'm here, yes?
that's what I was gonna ask, because like, does it matter which side you choose it from?
On this one, no. So here they were all the same, so it didn't matter because they were all 3s and all 6s.
But if it was isosceles, would it matter?
Yes, it would. So you'd have to pick, match the 2 that are the same together and then the one that would be different.
Okay.
The way that you'll tell which ones to match, they would need to give you a similarity statement, like we're going to do on the next question. Everybody good? All right, let's try the next one. So what they're telling us here, when they're asking us to find the scale factor of ABCD to MNOP, they're telling us that these are similar. So now what I'm going to do is match my sides. So I can go through and use my statement up here. So we're going to state that these are similar. So A, B, C, D is similar to MNOP. And now to find out which side matches, I'm going to look at the order of the letters. So AB is the first 2. So I'm going to match it with the first 2 here. So AB is going to match with MN, which is Y. So I can go ahead and put that in a ratio. So 12 over Y. Now I'm going to go and look for the next one. Let's find my next match. BC, second and third letter, matches with second and third here. So that's going to be 4 over X. And then I'm going to go and get my next one, and I can do CD with OP, which is down here. 14 to Z. That's a Z. And then lastly, and this is the most important one, 10 to 8, because this is going to give me my scale factor. So you're looking for the side that when you match them into the ratio, and I'll do this one in black so it shows up better, 10 to 8, this is going to be the scale factor. I'm going to reduce it because they both have numbers. I don't have an unknown. This will simplify to 5 to 4. This is my scale factor. So the scale factor is the same thing as the ratio of the sides. Now, I need to go now and find X, Y, and Z. I'm going to use this scale factor, and I'm going to make a proportion with the red, the blue, and the green here. So I'm going to set this equal to 5 over 4. Set this one equal to 5 over 4. Set this one equal to 5 over 4. Now I'm going to solve the three proportions to find the missing variables. So let me do the red one. I'll zoom in here. I'm doing cross products here. 5 times y, and I get 5y equals 48. I'm going to divide. That's not showing up very well. Maybe I'll try the black. 5y equals 48. Divide both sides by 5. I can't leave it improper because this is actually a side length, so I need to make it a decimal or a mixed number. 5 will go into 48 9 times with 3 left over. I'll just make it a mixed number. Now, if you made it a decimal, this would be 9.6. I would accept either answer. If it's a multiple choice question on a test, be aware that it could be either one. Next, I'm going to solve the blue one. Cross products. 5 times x, 4 times 4, divide by 5, and x equals 5 goes into 16 3 times with 1 left over, or 3.2. The green one, 5 times z equals 14 times 4, which is 56, divide by 5, and z equals 5 goes in there 11 times, 55 with 1 left over. So this is 5.2 also, 11.2. So now I found the values of x, y, and z. Now I can answer part C. Find the perimeter of each quadrilateral. So for the first one, they already had given me all the side lengths. So I'm going to add 10 plus 12 plus 4 plus 14, giving me a total perimeter of 40 units. Now for the smaller quadrilateral, I just found those 3 missing sides. So now I'm going to add 8 plus 3 1/5 plus, maybe I'll do it down here, 8 plus 3 1/5 plus 9 3/5 plus 11 1/5. Or you could add them as decimals. Once you add all of these up, you get 32. Now it asks to find the ratio of the perimeters. So now I take the perimeter of the first one and put it over the perimeter of the second one. I always need to reduce. I can divide them both by 8, and this simplifies to 5 to 4. What you're going to find is that the perimeter of the side lengths is the same as the perimeter, as the ratio of the perimeter. So ratio of side lengths which is also scale factor, equals the ratio of the perimeters. They're both going to simplify to the same thing.
How did you get 5/4?
Because
Like beginning part for the scale factor.
I took the yellow that I circled, 10/8, and reduced it to 5/4. So I found the two sides that actually both had numbers. Because I was given that they were similar. So because they were similar, I already knew the sides were proportional.
Maria, how did you know to put the 40 over the 32 and not the 32 over the 40?
Because they told you find it from A to ABCD to MNOP. So how it was originally asked for the scale factor at the beginning, I'm going to follow that same order.
Okay, got it.
Everybody good? So these two ratios of the side lengths and the perimeter, they're always going to simplify to the same thing. Pretty good on this slide? Yes. So I got 5/4 for the ratio of the side lengths, and I got 5/4 for the ratio of the perimeters. They're always going to be the same.
So for the first question, would you keep it with the variable or would you have to go back and add the actual value?
For part A? No, part A, the answer is this, the 5/4.
Okay, that makes no sense.
Everybody good now? Let's try another one applying this. So again, we're just looking for corresponding side lengths. So they're telling us they're similar. So based off my statement that's given to me, I can see that TP, which is right here, is going to match with the XP, which is right here. So I could write that. Let me write that in a ratio. So TP is going to match with XP. Now, I don't know TP. I don't need that one, sorry. But that's what's going to match. Let me just use the ones that I have that match. So I'm going to be using the TR, the beginning and the end, with the XZ. So I could put TR over XZ, because that's where the numbers are. The length of TR is 6 plus 6. So the length of TR is 12. The length of XZ is 8 plus 8, and that's going to be 16. I'm going to simplify that because that's going to give me my scale factor. So when I reduce 12/16 by dividing them both by 4, it reduces to 3/4. Now I can answer the question. It wants me to find the length of PS. PS, I could say, is X. PS is going to be from here to here, and it's going to match with the PY. So PS to PY. I don't know PS. PY is 20. I'm now going to take these two ratios and put them together in a proportion. So 3/4 equals X over 20. Cross multiply. 4 times X, 3 times 20. Divide by 4, and X equals 15, which is the length of PS. Yes. Yeah. Pretty good? Now we're going to see that perimeter information officially presented as a theorem on the next slide. Pretty good? Go on. So now here's our first theorem of chapter 8. Again, the number is not important. And this theorem is the perimeter of similar polygons. And it's basically what we just did. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So this is what I had done on that other quadrilateral question. We're just showing that the side length ratio equals the perimeter ratio. Basically, they're all going to reduce to the same thing. So on that previous example, remember we calculated the perimeters to be 40 over 32, and that was equal to the side length ratio, which was 5 to 4, because 40 over 32 simplifies to 5 to 4, and the side length ratio was 5 to 4. And then we just have our areas of similar polygons. One more theorem. And again, theorem 8.2 is not important to us. What's important is the name. So when we have similar polygons and we want to find the area, this time the side ratio, the side length ratio will be squared. Now, I know it's a little confusing here. Let me do one with numbers and then it'll make more sense. Everybody good? Okay, let's do an application of this. So in my figure, they're telling me that GHJK is similar to LMNP, and it wants me to find the area of LNMP. They gave me two side lengths, and notice these are the corresponding parts, because if I look up here at my statement, KJ, last two, matches with the last two here. So I can put 7 over 21 and reduce this to 1 to 3. Now to find the area of the larger rectangle, I'm going to take my scale factor and I'm going to square it, or the ratio of the side lengths, and then the area ratio becomes 1/9. I'm now going to use that ratio and solve the proportion. They gave me the area of the little one, and I put it over the unknown, which is what I was asked to find. The area of LMNP. So I'm going to solve the proportion. 1 times x, 9 times 8, 84. And I get 756. And that is the area of LMNP. So you find the side length ratio, square that, and then you would set it up in a proportion to find the unknown area. Now let me just show you one thing from the homework. Anybody still need this slide?